Oh hey, I know what you're thinking, and yes, I did get a new t-shirt. Thanks for noticing. So we're gonna slightly gloss over the fact that it's been like 9 months since we uploaded. We have a bunch of exciting content that we're gonna share with you. We have Insight landing tests, so we're gonna go through those clips and we're gonna explain them. That's the intro clip. So, before we get into the clips, let's introduce some of the changes that have been made to Insight. One of the biggest changes that we have is obviously landing legs. No more chute ejection system. Just got the landing legs. We're really happy with the design. It's basically a simple mass damper system. By using a little plastic syringe on the landing legs with a tiny air outlet hole, basically the pressure inside of those builds up and you get a really nice damping curve on all the legs. And we were really happy with them. They're super light, which is important because we didn't want to change our center of gravity too much. So we're happy with those. We also introduced a roll control wheel, just to make sure that when we're coming down through the unpowered flight phases, that there is not any roll that can be induced while we're not having full control of the vehicle. So we got a laser cut roll wheel. Shout out to Newport Manufacturing for that. It's really sick. It just adds a little bit of mass on a little tiny DC motor. It's super simple. We slapped a PID controller onto it, and then we just manually tuned it and tweaked it until we were happy with that. And it just tries to keep everything super stable around our longitudinal axis. With all of those physical changes, we also had a lot of software changes. We did a bunch of control stuff to figure out our landing algorithm. And basically our main approach was to try and do as much of the compute offline as possible. So we ran tons and tons of simulations with slightly varying initial conditions, and then we calculated the margin of error which we're acceptable with for landing, and then we just see how many of these simulations converge, and we were actually able to get a pretty good linear fit for most of this. And then we just take this linear fit, slap the linear fit onto the flight computer, we take in basically our current state at apogee, and we project it with this linear best fit line to what the best ignition time will be for the motor. I didn't think I'd get that right the first time. It's also worth mentioning that we introduced our very cool stereo cameras with fiducial marker tracking into the loop to help inform this landing algorithm. So basically the two cameras are running the exact same processing, and basically it just allows us to get really good tracking of these fiducials, and then from that figure out our position relative to these markers. So we have 4 of them spaced out evenly around the initial launch site, and as the rocket ascends, they come into frame, and we can actually get really good information about where the rocket is in vertical and translational space, which all helps inform the landing algorithm. Ready?
Ignition in 5, 4, 3, 2, 1.
So, as you can tell from the video, it's not a very good landing test. The rocket goes, and then halfway through the ascent burn of the first motor, second motor just goes, and it just goes to space. Halfway through, I gave up filming. Thankfully, the rocket survived pretty much. We broke one landing leg, but Insight has actually proven to be really, really durable. We mark this down to the 3 carbon fiber rod frame. It allows components to slide a tiny bit under really high load, which just keeps everything intact when you do take one of those very crunchy landings. So the main issue that happened there is the state machine thought that we'd hit apogee way sooner than we had, and it started the landing algorithm. It picked a descent burn time that was halfway through the burn of the first motor, which obviously just meant that we basically stacked 2 motors vertically, and away we went. So we went into fixing that. We put a bunch more work into the state machine to make it way more robust, and then we decided we would try it again.
3, 2, 1.
Yeah, let's go! We landed. We did the landing. It was pretty, I mean, I don't know if you count it really. The retro motor didn't fire. From our simulations, if the retro motor did fire, it would have been a really, really soft touchdown. But unfortunately, there was dirt from the previous tests on our actual JST connector for our igniters, which meant that it was not continuous. So that was not ideal for us landing. But we're pretty close. I don't know if you count it, probably not. But we did it. So that was all of our landing tests that have happened like over the course of like, I don't know, like 3 months. It's like 6 months ago. We know it's been a long time. We're very sorry. We do still love you. Luke and I have been finishing our university degrees, so that's taken a little bit of time out. And we've also been working on a very cool new project, which we will be announcing a bunch of stuff for very soon. It's almost at completion, and so it'll be very exciting when we do drop all the information for that. But for now, we're going to keep you in the dark a little bit longer. So make sure you subscribe. Make sure you follow us on all of our socials and stuff. People on our Discord already know a little bit about that secret project, so you should join our Discord if you want to know more about it. Otherwise, thank you for watching, and we'll see you in hopefully less than 9 months, but no promises, honestly, these days. In today's economy, it's hard to say. Love you guys.